And welcome back to another video in Introduction to C#. This is session 5 for the theory, and in this one we'll be going over a extended view of methods, how to search arrays, and that ugly word called documentation. Okay, so last session we basically had a recap on switching statements and a few command statements, and then we had 6 programs to write, which were basically variations on what we've already done, plus a couple of new ones around switch command and a few other things, but it was nothing major in it. So quick recap of methods. The method that we're most commonly seen so far is the main method. Now, what's a method? A method's just a block of code that can be called. So you can define your own method using the syntax of name and then the brackets. Now, you then call that block of code anywhere else within the program, and by just repeating that name and the brackets and the semicolon. So as a rule of thumb, we tend to use an uppercase letter to start the name, just because it makes it easier for us to distinguish it within the code. Doesn't have to be that, but certainly makes it pop out a little bit. So here we've defined a method called myFirst, which writes a line of string in the console, and under the main we execute or call that method. So if you're going to have a block of code that you're going to use repeatedly throughout your program, it's just a neat way of having it written once and then just calling it as you need it. That way you don't have to repeat the code over and over again. Makes your coding more efficient. Now, we can define parameters in methods. These are basically variables that work within the method, and the value that we define to put into those parameters when they are run in the method are called argument. So we can have a default value set when we define the parameters using the equal sign, but we can have multiple parameters defined by using a comma to separate them. When we do use multiple parameters, we need to match the arguments in both the number and order as we pass them into the method. So this can be quite tricky, as people tend to forget. Okay, so here's an example. So here, my cars, string CNAME, so that's the parameter name, and we're going to print a car that I've owned and have a placement, and then the variable. And then when we execute it, we define what that argument's going to be so that it knows what to print at each time it's executed. Now, when we put multiples in, there's your comma separating them. So car name, purchase, car that I've owned, that I purchased. So see name and purchase, and here we can see that the Datsun 260 used, Celica used, will be put in to those placeholders. Now, here I've decided to put a default in on the purchase value, which is used. So here, remember that the arguments have to be in the same order. So in this case, I can get away with only specifying the first one because the second one has a default value. So it knows what the second one is. On the second instance here, I've defined the second argument. Now, we can do this with strings, integers, doubles, whatever we have defined in variables. So basically the data types we can use in here. Now, when your method is supposed to return a value that's going to be used, then we need to change the way we use it. So in this example where we're using a simple primitive data type, which is integer or double, and we basically define the x and y, and we want to return the value of that equation out to be used. So in this example here, we have 2 and 7. So in my calc, so x would be 2, y would be 7. 2 times 7 is 14. So in the console, you would have 14 come, because that would be the returned value for my calc. To gain flexibility, so we don't have to keep everything in exact order, we can mix and match a little bit. We can actually do named arguments. So in this case, we are saying string car 1, car 2, car 3, and we're going to write car 3. And when we call my car, we still need the 3 arguments because that's what we've defined within the method. But because we've used the named argument method, we don't have to have them in exact order because the name is defined here and then the value. So as long as we have the 3 defined within the method being called, it doesn't matter which order we use them in. Now, here's a new one that I find interesting. You may not. But if we want to do the same equation multiple times using different data sets, we can create the methods defined using the different data sets but use the same name. That way, when we execute it within the main method, we can just call the same method but use the different types of data sets. So in this one, we're just doing a simple x plus y return. but we've set it up so that it'll do it either integer or double, but we only have to call the one name, and it will use the appropriate values as required. Next is array searching. So this one is a little easier than what some of the other situations that you can set up to do searches. I'm just going to cheat a little bit and go to the methods of find. So we've got find, find all, and find last. Each of these methods search for an element within the array that matches the specified condition. Now, this line here, which is as clear as mud, comes directly from the Microsoft documentation. It is confusing because they use the T all over the place, and their explanation isn't very nice either. But basically what we do is we have a function that we basically call an array find. We specify the array we want to do the search on, and the predicate is what we're searching for, what it's got to match. So here in the example, we're looking for a straight find. So we have a string of names, and we're going to find Bill. Now, the way this works is find looks for the first element that matches and then stops. It will return the very first one that matches. So here we can see we've got Bill and Bill Gates in the names. So I've got two Bills, but it will only return the first one. So the array to search is names, and we're going to be searching the elements which equals or greater than the element which equals string defined. Did a bit of a double gook, but that's what it is. Next is find all. Again, exactly the same syntax, except for the command is array find all. So in this one, again, we're searching for Bill, but this time we're saying the elements, and then we're going to lower string to find. Now, what this does is it converts this to lowercase, so Bill will match both of those and print them out. So as you can see, this little search function can be quite powerful and do lots of different things. Then find last, again, looking through our list of bills, it'll find the last element that contains Bill. So it's not an exact 100% match, because if it was just Bill, which is 4 characters, that would be the only one that it matches. But when we use the contains, well, we get every one of them matching, all the bills, but the last element, in other words the element with the highest index number, is Bill Gates, and That's what it will return. So that's a quick look at the find functions. There are many different ways of searching within the elements and how we can manipulate the matching process. This is the best way of saying it. So it is something to be explored. That's just the basic intro. Remember, this is just an introduction course. So just to whet your appetite. So the methods and the searching of arrays, and for more research, do the old search on the interwebs. Alright, for our documentation section. This is not a documentation how-to course, but with any project, you've got to do some paperwork. So we need to go through and do the paperwork because no job's finished until the paperwork's complete. So our document types that we generally come across within any project will be the requirements document, which has all the required specification laid out for us. Design document, which sort of breaks it down into how we're going to do the design elements, because normally various elements are broken up into different teams. Modular design is more flexible and you can get different people working in different areas, which means the overall project is completed faster because it's modular. You're working on various elements at the same time and it just ties all back together. Technical documentation is where we actually specify and describe all the programming components, like the algorithms used, what the functional modules are within the program, any flow charting, anything that explains what we're doing and how we did it. Next up is the testing document. This records our testing plans, our test cases, validation process, and test results. This is very important in going through and ensuring that we've met the requirements. This is how we double check to make sure that we've met all the requirements and that the product does what we've been tasked to do. This is the proof that we tested it, and we send in true and false values and see what happens when that occurs. Operational manuals are there so that the users or team members know what every element is occurring within the program and how that impacts other modules within the program. The user manual itself is basically the instructions or procedural steps for the users that are using the final product. So this is used as part of the training process when you're bringing new users on board to use the program. Part of that is the user manual so that they know what features are available and how to use it. Next is known bugs. So these are bugs or faults that have been found very late in the process that are earmarked to be fixed in a later update, or they were discovered, they have very little impact on the overall performance of the program, and on a cost analysis basis it's basically deemed that to fix it is more costly than leaving it in. Okay, so some of the advantages. Okay, we need to keep track of all the parts within the application. The programmers and developer need to understand all the aspects of what they're developing. It should improve the overall quality of the software because it's all documented. Everybody knows what they're doing, their individual part of the application. It ensures that all the knowledge isn't residing in a single place. Okay, if you're relying on one or two people and they leave, then all that knowledge has gone with them. So you need the documentation to be in place, kept up to date, revised, a record of the revisions, which one's the current, which one's superseded. Alright, so that everybody knows what's going on at any given time. Now, if you do this, you will see a cost benefit in the long run. Alright, don't think short term, think long term. Maintenance of the application will be easier because 6 months, 12 months, whatever it is later, when the same or a different set of programmers come in to make the modifications, fix those bugs, they've got the paperwork that explains what each step of the program's doing, what it is expected of it, and they then can go through and test their changes and see and compare those results to the previous results from the original testing documents and adjust all the paperwork. And because you continuously improve and keep your documentation current, that user manual and that list of bugs is constantly evolving and getting better, and users can be updated easier. So, some rule of thumbs. The document should be unambiguous. So, in other words, clear-cut, definitive, and specific to the requirements. It shouldn't be a rambling exercise. It's not a novel. You're just documenting what's there, what it's doing, why it's doing it. You don't need to repeat yourself within the documentation. If you need to reference something that's already been clearly defined, then you just put a refer to statement in there. Don't keep repeating yourself. When you're writing these, and I've seen it so many times, people forget the target audience of the documentation. Alright, so if it's a technical document, it's okay to write it as if you're talking to a fellow colleague. But if it's the user manual, you're not talking to DevNet person or somebody with years of experience. You're talking to somebody that just wants to use the final product and know how to do it, with no knowledge of what's going on inside of it. They just want to know how to use the application. They don't want to know the brilliance of what's happening behind the screen. They just need to see what's there. There's industry and state and federal standards, depending on where you are. In Australia, we have Australian standards. There's also international standards for IT. So there's plenty of standards that we need to adhere to and select what is most appropriate. Documents, as I've repeated a few times here, need to be up to date. They need to have revisions within the document so that a person, when they pick up the document, knows whether they've got an old one or the current one. So this is where putting revisions on your documentation is important, because it gives you a history of what's changed between each revisions and when that current revision is. So it's a record. It takes away that ambiguity that is present if you don't have some form of revision. Okay, so to give you an idea, it's not very good, but September date. Okay, so if I make changes to this Power Pack slide, chances are it won't be in September 21, and chances it won't be under that unit number because the training package has changed and this Introduction to Programming Skills unit has a new programming unit code. So the revisions will be clear, and when I refer to somebody in the future, they know what document and what version I'm talking or referencing to. And for those unlucky students that are actually part of my physical class, you get to log into the Discord server for this unit, and there's some reference documentation there that explains this in a little bit more detail. Takes you through to some other links that links you to the Australian standards, the ISO standards, and so forth, and gives a couple of examples of some of the document types. So all right, the interesting part. So this is where we'll go off and do some coding. So again, every program should be named in a fashion that describes what the program is. The coding should have comments in it so that when looking at it, you can understand what you're trying to achieve at each block of code. Now, the individual tasks. So create a program that allows you to enter your name and display it character by character. And that's an interesting one. So user input and then breaking it down and displaying it character by character. Many ways we can do that. Program which allows you to enter a number between 1 and 12 and will display the corresponding month's name. So I'll give you a hint there. Switch statements. Okay, again, there's a little bit more to that. Those two programming questions are basically out of Activity Week 5B sheet, and there's also another element in there for you to do, Not to spoil anything by the presentation. Alright, so third program. This one we're going to be sorting an array in descending order given the elements. So, there's the elements. So there's the elements. We want it in the original order, then descending order. But I thought the array sort function did it in ascending order. Some research required. Okay, next, collect input 5 times, ask the user for a search function, return the first match, return all matches. So input, if you cast your mind back to session 3, we did input a minimum 5 elements. The demo I did was on car makes. So whether it's a string function, integer function, whatever you want to make it, go off, have fun. There's plenty of scope there for you to play around with. Again, for the sad souls actually in my classroom, you have activity week 7-8 document. Now this document has 4 programs listed in it, and I want you to write a testing document for each program. So that's part of the documentation. Okay, you're given the code. It may or may not work. Remember, I didn't actually write that material. Put it into the Visual Studio. Look at whether it works, what will happen if you input the wrong information. Will it break? What's the criteria? How would you go about testing to make sure it's working correctly? Alright, so the good news for my students, they really like it when I say this. This is the final theory slide pack. Alright. Have we gone through everything within C#? God, no. It's an introduction course. We've gone through the basics. We've explained some more method usage, different ways of using methods and calling them. We introduced you to some of the search functions that can be implemented. We did a very, very brief overview of documentation types. There's whole units on creating documentation, so I'm not going to include it in this because this is an actual coding subject. And on this session, create 4 more programs, write 4, well, shouldn't be user manuals, it should be testing documents. I'll have to change that in my slide pack. So that's a boo-boo. The words is 4 testing documents to write. I was originally going to say user manuals until I double checked the training package, and the training package requires testing documents. So testing documents is what we're using. Alright, so as I said, this is the last theory. the next couple of sessions are just going to be finishing off all of the coding exercises, making sure you can write those testing documents and record testing results, and finalizing the assessment tasks that you need to submit. So for those looking at the video, we'll have a few more coding lab ones coming, but this is the last theory session we're going to have. I hope it's whet your appetite to continue to explore C# as a language. It's a relatively easy language to learn and have fun with. The other one that I find quite easy, especially if you're learning them close together, is Python, which is used a lot with automation. So dive in head first, learn, have fun doing it. It's worth the effort. So from me, it's basically bye for now. Until next time.